Dear students, in previous lecture we discussed Karl Pearson's correlation coefficient under the section of correlation. In today's lecture we will discuss rank correlation coefficient. Before starting rank correlation coefficient, I would like to compare Karl Pearson's correlation coefficient with rank correlation coefficient. I discussed in previous lecture that Karl Pearson's correlation coefficient lies between -1 and +1, and same can be said for rank correlation coefficient. It also lies between -1 and +1, but there is a standard difference given between these two correlation coefficients. Karl Pearson's correlation coefficient is some kind of direct correlation coefficient, that two variables x and y are correlated positively or negatively, means just change of direction, nothing else. But here -1 to +1 matters a lot, because rank correlation coefficient is about consistency of a data. How? Say here in this problem, which we will discuss after this comparison. In mathematics, 10 students are ranked, third ranked student, then it's ranked 5th, 8th, 4th, etc. And in statistics, same 10 students are ranked. Say if you see, the student who is having rank 1 in mathematics is having very poor rank in statistics, 10th, and the student having rank 1st in statistics is 7th ranked in mathematics. That means obviously the ranks of students is our inconsistency side, and -1 to +1 range of rank correlation coefficient actually shows this consistency. If it's +1, then it's perfectly consistent correlation coefficient. That means ranked 1 will be ranked 1, ranked 10th will be ranked 10, both the sides like that. But like this particular example, if inconsistency is shown, that means the rank correlation must be assumed as our negative side initially as per seeing this data. As you can see, the value of rank correlation coefficient is coming as negative -0.29, which was assumed initially because of this data. So it's all about consistency, not a direct kind of correlation. Then one more important thing which you must know, rank correlation coefficient here is symbolized as rho. Actually its standard symbol is a small r, and a standard symbol for Karl Pearson's correlation coefficient is also a small r. Both are in the syllabus, so I am using different symbol here, and in problems you can see rank correlation given by small r, so you can use a small r also, maybe rho. Important thing is to write the name. If you are finding rank correlation coefficient, write it. If you are finding Karl Pearson correlation coefficient, write that. And the last important thing before starting this problem, or that formula, that if in a problem it is asked to calculate correlation coefficient, neither Karl Pearson nor rank, nothing is written, only correlation coefficient, then that is to be taken as Karl Pearson correlation coefficient all the time. You must not confused in that. Rank correlation coefficient will be asked only if ranks are given in the problem, maybe directly or maybe indirectly. Okay, let's start the formula. Rank correlation coefficient sigma or rho, r or rho 1 minus 6 sigma d square, capital D, which we will discuss here in the solution, upon n square minus 1. So let us start this problem as I was discussing initially in this slide. 10 students are ranked in mathematics and statistics. Their ranks are given, and it is the simplest possible problem of rank correlation. Why? Because we need ranks, and ranks are given directly. If not given, then we have to create ranks, which we will see in further problem. Let's assume Rx and Ry as ranks given to us in ranks mathematics 3, 5, 8, 4 up to 1, 6, 9 are assumed as Rx in that first column. Ranks of statistics of same 10 students in that order are assumed as Ry, that is 6, 4, 9 up to 10, 5, 7, as you can see. Then capital D is nothing but difference of ranks, Rx minus Ry, maybe Ry minus Rx. Here it is taken as Rx minus Ry. 3 minus 6 minus 3, 5 minus 4 plus 1, etc. up to 9 minus 7 plus 2. Then capital D square as it's required there. So square of every value minus 3 is square, 9 plus 1 is square, 9 minus 1 is square 1. Then you have to add these all values in that last column of capital D square. You will find sigma capital D square. Here in this problem it is 214, and small n in that formula means number of participants in the problem. Here we have 10 students participating with these ranks in two subjects, so small n is 10. So that is the formula of rank correlation coefficient. As you can see, substitute values as required. Sigma D square is 214, then n square minus 1, n is 10, so 10 into 100 minus 1, and if you simplify you will get final value is minus 0.296 approximately, minus 0.30, and with that we complete the simplest problem of rank correlation because ranks were given directly in this problem. In next slide we will discuss other problem with creation of ranks. Question number 2. Compute rank correlation coefficient from the following data of marks obtained by 8 students in the papers of physics and mathematics. Now marks are given, ranks are not given, and we have to calculate coefficient of rank correlation. Then it means we have to create ranks as per the scores. Here you may not think over what is the maximum score, out of which maximum score students in physics obtain 15, 20, or out of which score. There may be different maximum scores also, it's not required. We need ranks. So with any maximum score we have to create ranks in this problem. How? Marks in physics, first column assumed as x, 15, 20, 27, 13, 45, then 60, 20, 75. Marks in mathematics assumed as variable y, 50, 30, 55, 30, 25, 10, 30, 70. Now how we will create ranks, that's important to know. Rx, that is rank for scores x, Ry ranks for score y. If we create these ranks, then similar work will be painting what we discussed in previous slide. As you can see, once Rx and Ry are created, then difference between ranks Rx minus Ry, capital D, then D square, and all those same formality, but formula is looking different, dear students. M1, M2, so something is happening there. What's happening? Let us see. Rx, how we can create? Let us see the top score. Top score is 75, so it is ranked 1 in physics. Rx is rank of physics because x is score of physics, so 75 ranked 1. Then 60 may be the next score, so ranked 2. Then 45 ranked 3. Then which is the next value? It is 27, so it's ranked 4th. Then we have 20, but 20 at 2 places. If no value or no score is repeated, it's quite simple. I hope you understand now. It's 1, 2, 3, 4, 5, 6, 7, 8, how you can give it rank. But if no repetition, okay, then it's fine, whether in x or y. Without any repetition, ranks are very easy to give, very easy to assign ranks. But here, as repetition is there, what should we do? Say 20, because 4th ranked is 27 score, and then 20 2 times, and we have finished rank 4. That means next rank will be 5th, and 20 is repeating 2 times, so will be 6th also. So there are 2 ranks, 5th and 6th, and numbers are 5 and 6, and repetition of 20 is only 2 times. Okay, so 5 and 6, and we have to take average of ranks. As you can see, it's written there, 2 students secured 20 marks in physics, so awarded ranks are 5 and 6. Then the average of both the ranks is 5.5, and you have to assign rank 5.5 to both these students. Alright, so it's clear. Then which rank is finished? 4th rank finished there, then 5th and 6th with 5.5, 5.5. So next rank will be the 7th rank, because we have finished 5th and 6th. And after 20 repeated 2 times, which one is the next one? It is 15. So 7th rank goes to 15. And the last one, I think this 13. So there were only 8 students, and we finished providing 8th rank to score 13 in physics. So it's finishing. We finished Rx. Assuming Rx, now Ry in mathematics. What about the top score? 70 there, first rank. Then the next score is 55 out of these all, second ranker. Then what about the next score after 55? It's 50. So it's third rank assigned to that 50. After 50, 30 at one place, 2 place, 3 place. That is after rank 3, 30 is repeating 3 times. Means rank 4, rank 5, rank 6. Do you understand? 50 was awarded third rank, and after that 30 repeated 3 times. Means 4th rank, 5th rank, 6th rank. We have to take average. Average of 4, 5 and 6. That is 4 plus 5 plus 6 upon 3. Average of 3 values. 4 plus 5 plus 6 upon 3 means 15 upon 3 means 5. So for these all scores equals to 30, we have to assign rank 5. So it's 5, 5 and 5. 5, as you can see. So here 30, 3 times repeating, and rank average 4, 5, 6. Average of these 3 is 5. So it's 5, 5 and 5 against 30. Is it okay? Then we have finished rank 4, 5, 6. So next rank will be 7. For 25 it's 7. Then because after 30 it's 25, the next code, so ranked 7. Then last code is 10 and ranked 8. So that's how we have to give ranks. And if no repetition is there in X or in Y, X and Y repetition is of no matter. Okay, repetition inside the values of X is mattering for Rx, and inside the values of Y is mattering for Ry. So that's how we created ranks. I hope now you understand. Now D is calculated as simply Rx minus Ry, as you know. 7 minus 3, 4, 5.5 minus 5.5, it's 0.5. Okay, 4 minus 2 is 2, and then say 1 minus 1, 0, etc. Then D square, squares of all these values of D and sigma D square, as you know that. One more important thing which you may check in previous problem or in this problem or in any other problem, whatever the type of problem is there, that is whether ranks are given or scores are given, repetitions are there or no repetition, in any case sum of that column D will always be 0. We don't need this column, sum of this column, sigma D is nowhere required, in no formula, but still if you add, you will check it is sigma of D, sum of this column is always 0 in any problem of rank correlation. So you can at least cross check, like in this typical problem, whether you assigned ranks correctly or not. For that, if you check sum of all values of D, it will be 0. Then at least you can confirm, okay, you assigned ranks correctly. Fine. Now, what is there in formula? Certain changes you can see. N square minus 1, 1 minus 6, then sigma D square. We are adding certain values. M1 and M2 are mentioned there. For what values? Because in that X series 20 was repeated 2 times, so we are assigning a constant M1 for Mars in physics, because X means Mars in physics. 20 repeated 2 times, so M1 is 2, number of repetition. Okay, and in mathematics, Mars in mathematics, that is in Y, repetition of 30 was 3 times. That means M2 is 3. So there may be few more repetition in X and Y. So you can give them M3, M4, and number of repetitions are the values of M1, M2, M3, etc. So here M1 is 2 and M2 3. M1 equals to 2 for repetition of 22 times there, and M2 equals to 3 for repetition of 33 times there. Okay, where Mi is the number of times a particular mark has been repeated. Okay, so we have 2 new constants which we have to include in the formula also. Those are M1, 2 and M2 equals to 3. In formula, there is a slight change. 1 minus 6 and n square minus 1 is okay. We have to add certain values with sigma D square, not 6 is not multiplied with sigma d square. 6 is multiplied with that whole expression. Remember that. Okay. So sigma d square plus, as m1 and m2 are two constants which we have to include here. So we have to add terms of m cube minus m upon 12 type for all values of m. So m1 and m2 are two values there. So m1 cube minus m1 upon 12 is added, plus m2 cube minus m2 upon 12 is also added. Suppose m3, one more repetition is there in either x or y series, then you have to add one more term in that formula, plus m3 cube minus m3 upon 12. Okay, so it's about number of repetition. How many values of mi are there? Only two. So two terms of this pattern are added here, and then rest is just about writing values. 1 minus 6 sigma d square is 81.5. It's 81.5. Okay, plus m1 which is 2. So 2 cube minus 2 upon 12, plus m2 is 3. So 3 cube minus 3 upon 12 whole upon n. 8 participants there. So 8 into 8 square minus 1 means 8 into 64 minus 1. If you calculate, that whole expression will be equals to 1. So 1 minus 1 equals to 0. As you know that r may be any value between minus 1 and plus 1. If it is 0, what kind of conclusion can be taken for this problem? That the data is neither consistent nor inconsistent. So it was about all important rank correlation coefficient.